Hello everyone and welcome to my channel. Today's video is going to be on enabling granular updates with multi-vector retriever in LangChain. This video is a follow-up video from a previous one that I did on creating a persistent multi-vector retriever. You can find the link in the video description or in the upper right corner. I've written a companion article on medium.com that will detail every steps of the notebook. Also, you will find all the code for my previous video and this current video on my GitHub. Both links will be available in the video's description. Why this video? Well, I needed a way to identify modified chunks. While LangChain provides an indexing mechanism to detect the inserted, updated, and deleted documents into a vector store using the SQL record manager, there's nothing equivalent for the doc store. Also, I needed to introduce a way to do granular updates so that we would only regenerate summaries and hypothetical questions only for the modified chunks. And finally, I needed to maintain consistent document IDs. So I introduced a reproducible document ID that will ensure consistent linking between document imports and their embeddings. Let's get started. Let's start by visiting the documentation on the indexing mechanism on the LangChain's website. Basically, LangChain provides an indexing mechanism that uses the SQL record manager that will automatically detect inserts, updates, or deletions. The reason is to avoid writing duplicate contents into the vector store, avoid rewriting unchanged content, and, very important, avoid the recomputing of embeddings. Because calculating embeddings is not free. So why would we want to recalculate embeddings on documents that were already embedded? The way that it works is that the record manager will calculate a hash on both the content and the metadata. So whenever one of those is changed, it flags it as a modified page. Let me explain. I've decided to recreate the notebook here on my GitHub for convenience, because basically I want to run the demo from the existing mechanism, and I want to run the same demo with my custom indexing mechanism. Let's start with LangChain's version of the indexing mechanism. First, you need to know that there's 3 cleanup mode. None, which basically doesn't do any cleanup. All it does is ensure that you will not have any duplicate content. Incremental will clean up deleted source, and full will clean up mutations of source doc and or the derived docs. So depending on your need, you'll have to decide on full or incremental. In this demo, we'll concentrate on incremental. Let's run the imports. Okay, we need a few modules to run this demo. We need the SQL record manager, index, the embeddings, and the vector store. Let's run this cell. Let's instantiate the vector store. And if you notice, in the original notebook, they were using Elasticsearch Store. I modified the notebook to use pgvector because if you're following from my previous article on creating a persistent multi-vector retriever, I provided a Docker container to host a Postgres database locally. Okay, so for convenience, I'm going to use Postgres because it's easier for me to demonstrate what's going on under the hood. Okay, so let's instantiate the vector store. And let's instantiate the record manager. Okay, the record manager is what's used to detect all the modifications. So the first thing we need to do is run a create schema. And by doing so, it will create the required table, which is called absorption record, to manage all the modifications. Okay, so let's start by creating some documents. Now I'm going to create 2 documents, one called kitty.txt, one called doggy.txt, okay, and which is some bogus content. Okay, so let's run this. And let's have a little helper function to clear our vector store. Okay, so let's instantiate this. and let's make sure our vector store is empty. And now notice that I'm importing the same document. So I'm only importing document 1, but I'm importing it multiple times. Okay, so let's run this cell. And as you can see, it says number added 1, updated 0, skipped 0, and deleted 0, because it's the first time. Okay, but I inserted 5 of them, but it only added 1. Let's go take a look. Let's look at the absorption record. There's only 1. And if I look at my embeddings, I only have 1. If I scroll to the right, I should see my metadata. Here we go. Okay? So it works so far. Now let's clear it again. And now let's add both documents. Okay? So now if I run index, I can see number added 2. Okay? What happens if I run it a second time? Okay, so let's run it a second time. Now it says num added 0, num skipped 2. This is the beauty of using the index, because it detects if documents were changed. If not, it just ignores them. Okay, and if we go back to pgn-min, refresh this, now I have 2, but it's not document 1 that was inserted twice. It's because now I've inserted document 1 and document 2. Okay, kitty and doggy. Okay, so let's clear it again. And now, because I was using none here, okay, now let's do it with incremental. Now I'm going to do it incremental, so it's doing the same thing. If I run it again, same thing. Okay, so as you can see, as far as managing duplicate records, both none and incremental do the same thing. Okay, if you provide no document as a first parameter in the index function, nothing will change. So if I run this now, you'll see everything's at 0. But keep in mind that if you were to use the full cleanup and you provided an empty list, it would automatically delete the entire vector store for the collection name. Okay. Now what happens if we mutate a document? The new version will be written and the old version sharing the same source will be deleted. Okay. So I have doggy.text. If you remember, doggy.text has doggy as a content. Okay. Now if I change it and put puppy, so technically that's an updated document. Okay, so let me change that and rerun the index. See, now it says 1 added, 1 deleted. Okay, it replaced the document. If you're using the full cleanup mode or full deletion mode, make sure that you present to the index function the entire universe of document, because any document that is not in the universe but is present in the vector store will be deleted. Let me demonstrate this. Let me clear the vector store and let's create an all docs that includes doc1 and doc2. Okay, so let's run this and now let's run the index. It should say num added 2. Okay, let's take a look. And I should have 2 records inserted in my absorption record table. Okay, so far so good. Now let me delete the first document. Okay, let's take a look at the list. Now I only have doggy. Okay, now what happens if I reindex all docs, which only includes 1 document, but my vector store contains 2. Okay, if I look at the embeddings, I have 2 embeddings. Okay, so one of the document is not present in the universe. So technically, if we understood the documentation, one of them should be deleted. Okay, so let's reindex it, and now it says num skip 1, num deleted 1. So now let's take a look. If I refresh this, now I should only have 1. And it should be doggy, okay, the one that was in my list. Okay, so doggy is what we have now. A little note on the source. If we read the documentation, it says the metadata attribute contains a field called source. This source should be pointing at the ultimate provenance associated with the given document. For example, if these documents are representing chunks of some parent documents, the source for both documents should be the same and reference the parent document. This is just like with my previous video, where we want to create derived contents like smaller chunks or summary question. But if you're using a multi-vector retriever, it's because you don't want to have the parent documents indexed into the vector store. You only want to have your derived content, like the smaller chunks, the summaries, and the hypothetical questions, indexed into the vector store. So the record manager recognizes the changes that are done inside the vector store, but there's no mechanism to detect if any modifications were made to the parent documents when inserted into the doc store. This is the whole point of this new video. So I will be demonstrating that in a few short minutes, so be patient. For those who haven't watched my previous video on creating a persistent multi-vector retriever, basically I was taking LangChain's notebook on their website on creating a multi-vector retriever, but in their notebook they were using the in-memory store, okay, which is not persistent. So there's no point. I mean, for prototyping it's fine, but for production application you need some persistence. So I decided to implement my own Postgres byte store. Okay, now to leave this notebook intact, I duplicated the notebook and I called it multi-vector rag with SQL record manager. Now let's modify this notebook so that it uses the record manager and the index function to save the documents into the vector store. Now the document is a PDF. It's a two-page document. First page on things to do in Montreal and dining in Montreal. Okay, nothing fancy. Now let's load my environment variables and let's load the documents. See, I have my 2 pages. And let's instantiate the vector store and the retriever. And now, since we're going to create child documents or child chunks, like summaries, smaller chunks, hypothetical question, we need a way to link the child with the parent. And a convenient way to do this is to use UUIDs. So let's assign an ID to the document. And let's take a look. We have a doc ID on page 0 and a different doc ID on page 1. So far, so good. Now let's create some smaller chunks. I'm going to create a chunk size of 400. So that should create 13 chunks, 13 child. But let's take a look. We now have the doc IDs of the parent. See, 33CA, 33CA, so on, 33CA, and F9, 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 F9. So the first, I don't know, 5 or 6 documents are linked to page 0, or the first half, and the second half linked to page 1. Now let's save this to the vector store using the index, and save the parent documents to the doc store using mset. Okay, so far so good. If I look at my index variable, it added 13. Let's take a look at the database. So in my byte store, I should only have 2, which are my parent. And if I look at the embeddings table, I should have my 13 embeddings. So far, so good. Now let's create some summaries. Okay, let's instantiate our summarized chain. And let's run this using the batch so that it runs in parallel. Okay, now I should have 2 summary, 1 for each page. Okay, but it's not in the right format. It's not a LangChain object. Okay, I need it to be into a LangChain document. So let's assign the metadata so that we get the doc IDs. And notice how I appended a suffix called summary. The reason I'm doing this is because if I don't supply the entire universe of documents, anything that is not in this universe but is on the vector store will be deleted. So my smaller chunks will be deleted if I'm not providing them here with the index. Okay, so let's run the index, and it should say added 2 and none deleted. Now if I go to the database, and I refresh this, now I should have 15, okay, including my summaries. Okay, should have 2. Here we go. I think you understand where I'm going with this. So I'm not going to do the hypothetical question. Now, what would happen if I re-import the document? Well, let's take a look. Let's reload the document. Now I don't have my doc IDs, so I need to reassign new IDs. Okay, but the problem is that the UUIDs are unique. So if I assign a new ID, I'm going to get a different one. Okay, now I have 2 new IDs. What happens if I create my smaller chunks? I get my 13 and I index them. Well, look what happens. 13 added, 13 deleted. Why is that? Well, it's because my 2 parent documents now have 2 new IDs. And what happens in my byte store? If I look at the byte store, I now have 4, or I ran it a couple of times. See, now I have duplicates. Okay? So the problem is that the record manager works well if you have a regular vector store. But if you're using the multi-vector retriever and you're saving your parent documents using the mset to the doc store, there's no way for you to know if the parent documents have been modified, because the record manager only works on the vector store and not on the doc store. Okay, so we need to figure this out, okay, because if we don't have a way to detect if a parent document has changed, how would we know not to regenerate the summaries or regenerate the hypothetical question? Because generating the summaries in the question is costing us money. So we need a way to do this. And this is what I did in this other notebook called Update Vectors. Okay, so multi-vector RAG update vectors is where I'm going to demonstrate how we can do this, and in a granular way. For this notebook, I'm going to use a different file. I'm going to use toronto.pdf, which is a 4-page document. Page 4 is food and nightlife, page 3 is outdoor activities, page 2 is cultural experiences, and page 1 is an introduction. So, you know, same idea. It's just I wanted to have more pages to demonstrate what happens if I delete a page or just modify a page. Okay, so let's load our environment variables and let's load the document. See, now I have 4 pages and I don't have any doc IDs as before. Now let's instantiate the vector store and the retriever. And now, instead of using UUIDs, I'm going to use a reproducible ID by content. Okay, the IDs won't change if the page content and the metadata don't change. Okay, so if you reopen the document and reassign the ideas, you'll get the exact same ideas. That's the whole point. So let's run this. Now let's look at my document. Now I have my 4 pages with the IDs. Let's move this like this. Let's run it again. And let's refresh this. See, I get the same ideas. Let's do it again. Refresh. Nothing changes. Okay? And that's the whole idea. Now, let's save the parent documents to the doc store. Now, before I was doing this while I was saving the, running the index and saving into the vector store. I realized I didn't have to do this, okay? I can do it separately without any problems. Now, instead of using mset, I'm going to use a new one called conditional mset. The difference is that mset didn't return anything, and conditional mset now will return if it's inserted, updated, deleted, or if it's skipped it. Okay, so now let's run it, and let's look at the result. And now it's saying that it inserted 4 pages into my byte store. And let's take a look. let's refresh this, and now I have my 4 records in the byte store. So far, so good. Now let's create some smaller documents. Again, like before, I'm going to use a chunk size of 400. Let's run this. And now I have my pages with my reproducible IDs. Okay? And I also added a type, because I'll explain that in a minute. Because when I run the update, I need to submit the entire universe, okay? But the whole point here is that I don't want to recreate smaller chunks if I don't need to, okay? For smaller chunks, it's not that bad because, you know, it's local. I don't have to call the LLM to generate a summary or a question, but I still have to call the embeddings, okay? So what I'm doing here is that I'm searching into the embeddings file for all the embeddings that were skipped, and I'm including them in my universe, okay? So that when I save it using the index, I provide, let me show you, well, you see here, I provide all of the documents, even those that have not changed, but I didn't recreate them. I fetched them from the table, okay? And if I look at the index, now it's telling me that it inserted all of them. In this case, it didn't fetch anything. But if I run it again, let me run this again, and index it again, now it's going to say skip, okay? Because it says there's no point of recreating the embeddings because we already have them, okay? So this, we could do that with the regular record manager to a point, okay? But now let's create some summaries, okay? Now let's instantiate the chain, and let's call the chain, but same thing. We're going to read the embeddings file to get the summaries that we already have. In this case, we don't have any, so it should produce 4 summaries. And they should all be assigned to the doc ID of their parent, okay? And then again, here I added a type called summary. Now let's save those, and it should say that it added the 4 summaries, okay? Now let's create the question. Let's run the function. Let's instantiate the chain. And again, let's create the questions, okay? Again, I'm fetching into the embeddings file for the missing question or the questions that were skipped, and I'm adding them to the universe. In this case, they're all new questions, so they should all be inserted, okay? So they're all inserts. So far, so good. Okay, now, what happens if I modify the document? For now, I'm just going to modify the first page. Just going to add a few words, and I'm going to print this to recreate the PDF. And let's save this, replace it. And now, let's re-import the document. Okay. Now I'm going to reassign the reproducible IDs. And I still have my 4 pages. And let's save this to the doc store. And now I should have 1 delete and 1 insertion, which is to be expected because the first page was modified, so it deleted it and inserted the new one. Now let's create the smaller chunks, and we have 9 index, and now since there were many smaller chunks per page, then it deleted 2 and it created 3 because we added some wording, so it probably change the recursive text splitter algorithm. Okay, so far so good. Now for the summaries. Should only change one. Okay, so let's rerun it. And I still have 4. And if I run the index with IDs, see, same thing. Deleted 1, added 1, and it skipped 3. So in this case, there's only one summary question that was generated. Okay, so we only called the LLM once instead of 4 times. So if we were to use the regular indexing mechanism provided by LangChain, we would have regenerated 4 summaries. Now, you could say it's not much, but let's wait for the questions where we have 5 per pages. So let's run this again. And now we have our 20 questions. Now let's run the index and let's see what happens. See, it deleted 5 or added 5 and deleted 5. Okay, so mission accomplished. Okay, so that was the whole point of this video. You can see now that creating a multi-vector retriever can be challenging if you have a very large number of documents that you need to import into your vector database. And especially if you want to create some summaries and hypothetical questions, you don't want to be calling the LLMs every time you're refreshing your vector database. So if you like this video, please take the time to subscribe to my channel and like this video. This really helps the YouTube algorithm. Thank you very much for watching me.